welcome to my TED Talk. No, that was another one. Sorry, got the one wrong. Welcome to my talk. I'm just a random speaker presenting what I believe could be a very nice event loop fairy tale. So we're gonna go about this as if it was a story, really, a fairy tale, for really. So let's start our story with, in a server definitely far, far away, probably in the cloud or serverless, I don't know. But first, let me present myself. I am Lorenzo Pieri. I am the bard that shall sing, no, I'm not going to sing it, but that shall sing the story. I'm a full-stack wizard at Birdie, Schrödinger hat, Brotherhood co-chief, which just means that I'm part of a community that does open source, and we also organize tech conferences and events in Italy, and sometime soon also in France and the UK, but we're going to see about that. And also you might not know me as 404 answer not found. I am part of this wonderful organization and company from the United Kingdom, which is called Birdie. Now, Birdie's vision is that to envision actually a world in which we all can flourish with confidence as we age. We work in tech for good, and we are trying to reinvent care through technology and enabling older adults to thrive at home. We also have quite a few openings, so if you're interested in a full remote role, with full stack role in the JavaScript Landia, please just talk to me after this, and I will be very happy to throw you a thought bag, and then we can talk about the actual role. But aside from that, it was history. So, a long, long time ago, in a time before the harmonious realm of Node.js was even a thing, the vast and expansive code world was ruled by powerful kingdoms. Now, these powerful kingdoms were allied with these magnificent, glorious knights. But let's not talk about the knights, but rather of what they were doing. And what they were doing is that they were fighting the dragon blocks. Now, the dragon blocks, you don't really want to meet them, especially if you're like in the real fantasy world, actually living it, actually doing something about it. And so, the knights from Javadom, from Pythonville, and from the kingdoms of the many seas would fight these blocking dragons, and they all had their methods of doing it, and fighting what was blocking their way of actually executing processes. Now, they used to live for these battles because they knew how to handle them, but really, some of them thought there must be another way, maybe a simpler way, a way to make this a little bit more comfortable for a warrior experience instead of a developer experience sort of thing. And so, enters the Knights of the Thread. These incredible, valorous knights would fight all the dragons with the methods that we just talked about. But all they knew was that they would have to spawn threads, which were their magical weapons, so that they could use them to apply logic and processing to asynchronous calls, right? Which is great, it's fair. All of them had their own system, like the Kingdom of the Many Seas. While the common folk lived their lives sequentially, that's what would happen in that kingdom, there were legends of magical threads, and each having a life of its own. And these threads, known as POSIX, could be summoned by only powerful wizards that actually knew what they were doing. So it wasn't easy to get into the POSIX magic, really. Meanwhile, in the sprawling landscapes of Javadom, knights didn't face dragons alone. They had the assistance of an order called the Nio Order. Knights skilled in managing battles without directly engaging the dragon, and thus avoiding the pause and wait strategy thereof. Pythonville, on the other hand, also knew a little bit of magic here and there. There was this new magician, he brought spells talking about async IO, but nobody really knew what they were doing at that point, because they just wanted to resemble async, but they weren't really good at doing it. And so, something else must have existed at that point. And it was during this era of innovation and search for efficiency that the tales of Node.js began to spread. The tales spoke of a realm where tasks just flowed smoothly, like a river, where no challenge halted the progress of the kingdom whatsoever. And that was all thanks to the fairy known as the event loop fairy. But let's haste and actually see what the Lands of Promises would look like. So, the Lands of Promises was actually this very beautiful land with just a single long towery castle just, foreseeing the entire realm. And with it, there was the single-thread castle. Now you would think, being only a castle without maybe walls and defenses and whatnot, it could be attacked quite easily by the blocking monsters, the blocking dragons thereof. And you might be right, that could have happened, but once you knew what you were looking for, because it wasn't like any other castles, you would also know that if you were really good at being a knight in the single-thread castle, you would be able to defeat any dragon because you never had to fight dragons at all at that point. That was the whole point of this land. And, whispers filled the older kingdoms. The age of the land of promise had dawned, and all eyes were on the castle of the One Thread. What did lay inside its walls? How did the event loop fairy weave her magic? The quest for knowledge and the lure of this new kingdom was just the beginning. But who lived there? Well, the inhabitants of this magnificent kingdom were task holders. So each of them had a task, and each of them knew exactly how they should have behaved when entering the village of the event loops. And they knew about the existence of the fairy mother and how she would act upon the event loop, this magnificent magical thing. And if you look closely, well, of course, you wouldn't notice anything from these images because this is, AI doing its things. But if you look closely, you'll notice something unique about its inhabitants. And that would be that each one of them could hold as many tasks as possible, but they were only able to actually carry out a task at a time, or actually to handle one task at a time, which was magical, and you would think very slow, but it wasn't, because they knew exactly where they needed to stand to make sure that everything worked just fine, that everything was in line with how the system operates. So, like the village blacksmith, who forges and converses, or the baker who bakes and sells simultaneously, Node.js operated on a similar principle. While one task is waiting to complete, it doesn't idle. It picks up the next task, and all the villagers are there very happy because at least at some point, each one of them are going to get their tasks, their necessities operated by the Node.js fairy, which is great. But let's delve a little bit deeper and meet our first key character who ensures that every tale in the village is told in order. And that would be the noble Sir Colastak. This magnificent, valiant knight of asynchronous, defender of the promised lands, first of his name, liberator of processes, and also mother. No, that, again, another thing. But you know what I mean, right? Upon the highest tower of the castle of the One Thread stood the vigilant and steadfast protector of the land of promise. And that would be Sir Colastak. His armor, a gleaming silver that caught the light of the Promise River, was engraved with intricate details representing functions and events and callbacks. It was said that Sir Colastak had an uncanny ability to remember every task, who handed it over, and what was to be done with it, all in perfect sequence. The townfolks admired and respected Sir Colastak, not just for his might, but for his impeccable sense of order. He was tasked with a sacred duty, to keep a watchful eye on the queue of tasks and see them executed one by one. Even as tasks poured in from every corner of the kingdom, his discipline ensured that they were tackled in the order they arrived, a method known in older times as last in, first out, really. But that's another story. Beside him, always fluttering around with an excited air, was the event loop fairy. She'd whisper to him about the importance of certain tasks, nudging him when an async task result was ready, and ensuring that callbacks from the callback square were attended promptly. This synergy was a sight to behold, and Sir Colastak, with his orderly approach, and the event loop fairy, with her insights into the asynchronous world, endured a harmonious rhythm. So, without further ado, let's see where they operated. Well, they used to operate in the heart of the village, and that would be the loop. Now, imagine a grand magical carousel, and that would be the event loop in our use case, in the heart of the village marketplace. The carousel has different segments representing timers, callbacks, and other tasks. All those magical things that we don't really care about because we're just, pushing stuff on a keyboard. That's the only thing we do when we type JavaScript, really. But the real magic is that the event loop doesn't work alone. It never worked alone. And so you would see that the magical fairy and Sir Cola Stack would always be together in parallel, working together, to make sure that the heart of the village was prospering and never blocked. So that all the economy and all the tasks that were going on at that point would never be blocked by anyone whatsoever. And sure, the villagers were really good at it. They knew that they should never have brought a blocking task, because then that villager would actually turn into a monster if you think about it. Because if you block the flow of the place where you live in, you're not actually helping out that much. So some of them, when they tried to do that, would be a little bit blocked by this defense mechanism that were held inside the event loop city and the village. And, well, they would go somewhere else. While other tasks that didn't block the loop could, not refrain from doing whatever they wanted to do in the task sequences of the market, others would be picked up and sent to the desert of asynchrony. Now, when those villagers wanted to do something really ridiculous like blocking the event loop, they would be picked up and someone would tell them, okay, you need something, and I'm aware that you're gonna block me because I'm the loop now. So instead of blocking me, go on a quest, an adventure, a journey, and learn what you want to do and what you want to become at some point without blocking the road to other tasks and villagers. So when you do that, take the road of the desert of asynchrony and reach out for the elves, because at some point you're going to reach the forest of thread pools. When you're going to be reaching the forest of thread pools, and it's a hard journey because you never know how much it's going to take for you to get there, you will find that there are prosperous and really magnificent working elves there waiting for you to make sure that you enter the LibUV forest and meet the LibUV elves. Now, these elves are not only the owners of the LibUV secrets, able to magically spawn as many threads as they like, which is something that goes against the principle of the one single thread castle, but they're also, they own the entire thread pool at that point. And they are able to spawn as many as they want. So, well, depending on the system of capabilities, of course, depending on how many trees you have in this magical forest. But when that happens, they will collect all the magical asynchronous tasks that were deferred from the main village, collect them all, teach them how to do their magic, teach them how to finish their essence and what they wanted to be and become, and then, once they've played their magic on this task, they would pack them up, little by little, and just send them back to the town, which is always a great idea, I guess. So, again, as tasks enter the forest, they are handed over to various glowing workshops, where elves diligently handle them. These elves, if you think about it, could symbolize parallel processing threads in Node.js, and how tasks are like reading files or making database calls are all coming together in this thread pool to make sure that they are handled efficiently without blocking anything at all. So, the key takeaway in this is that the LibUV forest really is where the magic of asynchronous happens and is processed in Node.js. This is where the things truly happen and unfold. So, the tasks from the desert coming from the city find their purpose in this forest because they unveil what they're going to become. So think about file system read. You can't do that in the village because that kind of magic is going to block the entire system, the entire scope of the marketplace. But if you send it to the LibUV forest, elves will know what to do, and they will get all the file content that you want, they will hand them to you as a task holder, and then they will send you back on your way, which is great. And that is exactly what happened, because when that is done, after being processed and readied, this task by the elves of Threadpool, the task will be given an emblem of completion, like a shining beacon. And these will actually guide them back to the heart of the land of promise. Riding on sweet winds, they will retrace their path, crossing the desert and arriving back at the event loop market. And the market will welcome them back, because at that point, they will not be blocking. They will actually efficiently go back into the system and sequentially and synchronously give you back the response at that point. Now, one good question that a magician might pose themselves would be, will these tasks arrive again in the exact same order they went to the LibUV forest? What do you think? Like you, what do you think? They're not going to arrive in the same order. Are we okay with this answer? Do you also think that? You? Yeah? Okay, yeah, that's correct. That's exact. Because the thing about this asynchronous task really is that independently of the fact that they might be pretty big or pretty small, they run and they get the answers they need at different speeds and times. And so you know what you're leaving behind, but you never know when you're going to get back the answers. The promise of the LibUV elves, though, the magic behind it, really, is that at some point you are going to get the answers you want, unless you block the thread and you kill the entire forest system, which is not very sustainable. Don't do that. But once you get back the task go back into the city, and they will join the queue once more. So, LibUV forest, the external mechanisms, they will complete the processing of the async tasks, and they will make them return. Some tasks might finish quicker, we said, while others might take more time. It's not always in the order we sent them. We know that. We don't really care too much about it. What we care about is that when those tasks join the queues once more, and imagine the task like those glowing orbs over there, when that happens, the tasks are going to be set back to the queues on which they belong, and those callbacks are going to be called back by someone inside the event loop, circle a stack, and it's going to make sure that whoever needed that piece of information, that piece of processing, will get that information back. Great. But we must always remember that everything like this is a little bit fantasized, and sure, great, it will work because, you know, that's like the magic of stories. Everything is just going to make its way out of magic country or whatever. But the real thing is that we must always think about the menacing dragon blocks. And as we're saying there, some creatures are to be feared, some other are to be controlled. Blocking dragons should be neither of those. They should be understood and never underestimated, because you have to accept the existence of these beasts, of these magnificent beasts, and the usages that you can make of them, really. Because you're always going to need to read a file in your system. You're always going to need to make a database call at some point in your application life, right? So you have to accept that these kind of calls exist, and they're beautiful because you can use them at your best. So learn how to use them. And when you will learn how to use them, you will actually be able to make asynchronous calls in a very easy and simple way, because you will have known the system. Now, how do we get to know the system? Well, with a little bit of magic. And we do that by knowing which phases comprise the event loop. The event loop is built on 6-ish phases, truly. And if you go over the internet, this other magical landscape which no one talks about, you're going to notice that there are different images showcasing how this loop works. And every time they show this loop working, you're always going to see an actual loop, like a circle, or sometimes some arrows going back and forth, whatever. But the main point of this is that there are going to be these 6 phase calls. Now, I'm wondering, how many of you know of these phase calls? Can you up your hand? Are you aware of how these phases work? No? Lovely. That's great. Okay. So, we will talk about these phases, but what I wanted to convey to you by showing all of them is that even though you learn them by heart, which is practically important, you don't really need them all that much, meaning that once you learn how to play the intricacies of the system, you will learn that you are actually using these phases at your best without actually needing to say, oh yeah, I'm on pending callback phase. No, that's not going to happen. You're just going to enjoy programming asynchronously, because you will stop thinking sequentially somehow, and you will actually start to embrace the fact that things are going to work out eventually. That's like rule number one. Eventually, things are going to work out. And that is all the event loop is all about. So the key is that knowledge is everything. Those were the phases that are mostly described when we're talking about the event loop phases. But knowledge is everything. And sometimes during the phases there are very intricate scenarios, and some of them would be something like process next tick. I don't know how many of you are using Node.js daily in your work, but it doesn't happen often to use process next tick. But once you learn how to use that, you will have the power to actually control the loop. You're not just playing the loop. You're actually in control of it. And then there are other things like set immediate or set timeout, which sometimes they're timers, sometimes they're just another phase. It's like adolescents, really. They don't know what they want to be. But it's great. So let's see what the event loop really looks like. So before even looping around things, we must be aware of what we are doing. And what are we doing? So when we are in this village of the event loop, all the tasks of the villagers really are processes and functions and things like expressions that we want the system to handle for us. And we have all these functions. Let's continue with that. Functions and expressions. We have all of them, and they must be stored somewhere. And they're going to be stored on the heap once they are inside the system. The call stack then is going to take into itself the fact that it will need to be sure that those expressions and functions are going to be called at some point, hopefully sequentially, but you never know. And the calls are going to happen like barrels of meats or like, bottles of beers, whatever. But the thing is, you might see all the designs and drafts of this call stack thing as many times as you want. You don't really need to care about it. As long as, as everyone gets their own meat and exactly the meat they wanted in the quantity they wanted, everyone's going to be happy. Are you questioning your bartender when they get you your classic beer? Probably not. So that's the same for the event loop, pretty much. What you need to understand is not how memory is dealt with, which again, internals, very interesting, but not the core of this talk. What you need really to understand is how the loop works. So, this is the loop. This is the only thing the loop is, really. It's just a bunch of things happening sequentially, and then again, and so on. The first part of the loop would be timers. And this is exactly how it would be shown in the usual suspects of the designs of this diagram. But truly, it's always next tick. So keep that in mind. Next tick, micro tasks, very important. They're not really part of the loop, but they are sequentially engaged with the loop all the time, anytime something happens. So let's say we have a timer. When we register a timer, which could be a set timeout with 0 milliseconds and a callback inside of it, the callback will be registered and executed inside that timer phase, which is not just a phase, it's actually a queue. And as any queue, you get your processes and the callback, you put it there, and at some point during the loop, it's going to be executed. And you don't really need to care about when that is going to happen, because you know it's going to happen if you coded well your system. Then callbacks are going to happen. And that is the other important one. When callbacks are there, that is going to contain IO callbacks, which is something that you do when you access like the file system, or you make an HTTP call or a database call. That is the other phase. Now I wonder, why is idle prepare a very small scroll on the screen? Well, the reason for that is because you shouldn't give a single S about what idle prepare does. Sure, you can learn the event loop, but that is just called internally. You're never actually going to call idle prepare, because that's a Node.js thing. So whenever they ask you, yeah, but there are so many phases in the event loop, no, there aren't. I don't care about them. I care about timers and getting them right. I care about callbacks and IO queues getting them right. I care about the poll phase, of course, because the poll phase is actually the loop waiting on itself for the call stack to actually have callbacks to call and execute. So the poll phase is very important because it's actually The rounding one is the one waiting for things to happen all the time. And then we have the check phase, which is also quite important because it's waiting for the set immediate callbacks. Now, those are many different ways and callbacks. You have like the timers, which are like set timeout and set interval, behaving differently depending on which one you choose. Then you have the I/O callbacks. Then you have the poll phase that actually takes everything and tries to execute it. And then you have the check for set immediate. Once you learn that those things are actually happen sequentially in an infinite loop, if you never block it, then you're actually able to use the loop at your best capabilities. Because then you might be waiting for a file system read to happen, but you also want to make sure that that happens sequentially and programmatically, not just behaving on the time of the loop, but also because you want it to sequentially work in the way you intend it to, which is not so easy in Node.js, because sometimes it happens that you expect one thing to happen after the other, and they really switch for no apparent reason. That's like the weirdness of the loop. If you know how these phases work, though, you're going to make sure that one thing happens exactly when you want it to happen. And that is when you make use of next tick and microtask, which promises, just to make it clear. If you know when to use process next tick or microtask, which are going to happen each one of them between each of those bigger phases that you see. So timers, next tick. Callbacks, next tick. Poll, next tick, and so on. If you know about this, you're going to be able to actually empower yourself of using exactly the right phase at the right time, and things will happen the way that you want them to be. You will be like a magician of time, if you want, which is great. So, a little exercise. Oh, by the way, there is another one, which is the close callback, the close phase. Unless you need to close the program or wait on a close event for a socket, for example, again, you're not going to use that phase. Well, you are going to use that phase, but you're going to do it anyway. So you don't really need to mess with that phase at any point. So just have fun with the other ones. Learn to control those fours, and you'll be a magician in no time. A question for you. Which magic scroll would first be read by the mages? We have 5 scrolls. The ancient scroll of set timeout with 0 milliseconds. The ancient scroll of set interval, which is a repeated process. The ancient scroll of process next tick. The ancient scroll of set immediate. And the boring ancient scroll of console log. So, of course, there's going to be winning prizes. So, can you answer my question? White shirt. Yeah, yours, the smiling guy. Which one is going to be called first? 5? Everyone agrees it's going to be number 5? Do we have someone not agreeing with number 5? Which would be fair. Nothing against that. Okay, everyone agrees. That's good. Means you understood it. Yes, console log is going to be called first. The reason why that is happening is because console log is actually a synchronous call. So it's never actually going to end in the event loop unless we put it inside a callback. So imagine your JavaScript file, lots of expressions, and then a random console log over there. When that file gets registered inside the development, the actual language, when you run that file, console log is going to be registered in the stack, but because it's synchronous, it's actually going to run first, even if it's coming after those other scrolls, those other expressions. And that is because on the registering part of the execution, that is just going to happen, while the others are going to let the loop start and run. And when that happens, callbacks are going to be registered, and some of them are going to finish in at least 0 milliseconds, which is going to sound almost immediate. But sometimes it could be a little bit more than 0 milliseconds, so it's really a lie if you think about set timeout. But yeah, order matters, yes, but what matters really is the fact that you learn how to play this card, because it's a little bit of a game of poker once you get into the Node.js phases. So learn your cards and you'll do great. And that is how it would work out. So to near the ending, strength is found in the mind, but it's also accrued with time. So you can learn all the Node.js phases you want. You can become a master magician wizard in how to do timers and callbacks and process next tick and whatsoever. but you need to be aware of what you're using, because sometimes using the best trick can lead to actually not complying with how the system should work. As I told you, process next tick is magical, but if you use it too many times and in the wrong places, it's actually going to slow you down, while what you intended, of course, would be to make your application faster. Again, thank you. I'm Lorenzo Pieri. You can follow me on those places. My website is 404answernotfound.eu. It's where I write random stuff. If you want to get part of a beautiful open source community that is called Schrödinger Hat, that would be us at the conference we organize in Florence, Italy. It's going to be in March 2024. Date is not there yet, but if you go to osday.dev, sometimes in the coming weeks, there's going to be more infos. And if you want to become speakers or first-time speakers, that's also a great chance, because we have a call for paper that's going to be opened very soon. Thank you very much, everyone. I don't know if you have any questions. If you do, please allow yourself to ask. Otherwise, thank you for coming to listen to my non-TED talk. I really appreciated you being here. I know it's 5 p.m. and yeah, thank you.